All right, so we're going to practice graphing some of these exponential equations. So this is graph the function and then find the y-intercept in the equation of the asymptote. Okay, first time a lot of you guys have seen this word before, asymptote. We're not going to worry about this right now. You guys can go ahead and cross out asymptote. We'll worry about that when we're a little bit more ready for it. Okay, but it says graph the equation y is equal to 3 times 2 raised to the x power. Okay, this is in the format y equals a times b raised to the x power. It's going to be an exponential function. Okay, and I can't say this enough. Anytime I ask you to graph a function, plot some points. Plug some numbers in for x, get some y values back, and then plot those points. Okay, and you should always pick the easiest numbers to plug into that equation. Okay, what is the easiest number to plug into this equation? 3 times 2 raised to the x power. Okay, 0 is almost always a really good start. Okay, let's plug in 0 into this equation. So if I plug in 0 in for x, I'll have y is equal to 3 times 2 raised to the 0 power. Okay, got to be careful here. Okay, got to account for order of operations. The first thing I got to do is I got to do the exponent. 2 to the 0 power is equal to 1. So when I simplify this, it's the exact same thing as 3 times 1. Okay, 2 to the 0 power is 1, 3 times 1 is 3. Okay, so when I plug in 0 in for x, I should get a y value of 3 back. 0, 3 is right here. Okay, let's keep going. Second easiest number to plug in, almost always, is the number 1. Let's do it. Y is equal to 3 times 2 raised to the first power. Okay, 2 to the first power is 2. 3 times 2 is equal to 6. When I plug in 1 into this equation, I get back 6. So let's plot it. 1 unit to the right, 6 units up, right here. And let's do one more. Third easiest number to plug in. Okay, we've already got 0 and 1. Let's get 2. Y is equal to 3 times 2 squared. Okay, 2 squared is equal to 4. So if I got 3 times 4, it's equal to 12. I know that the point 2, 12 is on this graph, and it's already off the page. It's way, way up here. Okay, always a really good idea to get some numbers in the negative direction as well, to the left of 0, to understand what it looks like on both sides of the equation. Okay, so if I plug in negative 1 into this equation, I'll have y is equal to 3 times 2 to the negative first power. Okay, and if I remember my exponent rules, 2 to the negative first power is the exact same thing as 1 over 2. This is the same thing as 3 times 1/2, and 3 times 1/2 is 3/2. Okay, so when I plug in negative 1 into this equation, I should get back 1.5 essentially, which is right here. Okay, so we're kind of seeing that curve shape once again. But let's get one more point. Let's get negative 2. If I have y is equal to 3 times 2 to the negative second power, 2 to the negative second power is the same thing as 1 over 2 squared, which is 4. 3 times 1/4 is equal to 3/4. When I plug in negative 2 into this equation, I get back 3/4, which is a little bit bigger than 0, but less than 1, somewhere like right there. Okay, so I plot it, and I connect my dots after that. It should have a nice smooth curved pattern, and it should look something like this. Let me erase that actually. This thing is going to stay above y is equal to 0 the entire time. Sorry, it's a little bit crooked, but it should look something like that. Okay, kind of a nice smooth curve going up and to the right. Okay. It's asking what the y-intercept is. What is the point in which this graph crosses the y-axis? We can look straight up and down here, and it's that point right here. What is the number at which I cross my y-axis? It looks like it is equal to 3. When I plug in 0, I get back 3. Okay, let's do one more example. Y is equal to negative 1/2 x. Okay, the negative is outside of the parentheses, so b is still positive, but my a value is equal to essentially negative 1. Okay, this does meet the requirements for exponential functions. Okay, so to figure out what this looks like, let's plug in some points. What's the easiest number to plug in? Every single time, the easiest number is pretty much always going to be 0. Let's plug in 0. Y equals negative 1/2, b is still positive, raised to the 0 power. Okay, 1/2 to the 0 power is 1, and if I throw a negative in front of it, it should be -1. Okay, so I know I have the point 0, -1 in my graph, which is right here. Okay, first time we got a negative number, but that's okay. We've got a negative in our equation. Let's keep going. Most of the time, the next easiest number is going to be 1. Let's try it. Y is equal to -1/2 raised to the first power. Okay, 1/2 to the first power is just going to be 1/2, and if I throw a negative in front of it, it should be -1/2. Let's plot it. 1, -1/2 is going to be right here. 1 unit to the right, half a unit down, like so. And then let's get one more going to the right. If I plug into y is equal to -1/2 squared, remember this 2 distributes to the top and distributes to the bottom. So it's the exact same thing as 1 squared over 2 squared. 2 squared is equal to 4, 1 squared is equal to 1. If I throw a negative in front of it, it should be -1/4. Okay? So we're to get a pattern, or get a feel for the pattern, okay? See like when it starts getting really small versus when it starts getting really big. So if I got -1/4, 2, -1/4 should be just above that line, or just below that line rather, but somewhere like right about there. 2 units to the right, 1/4 unit down. Okay, now let's get some negative numbers. Let's plug in -1. Okay, if I got y equals -1/2 raised to the negative first power. Okay, kind of a lot going on here, but let's distribute. So this -1 is going to distribute to the top and to the bottom. And basically what happens here is if you have a negative exponent, the top and the bottom are going to flip. So the 2 goes to the top and the 1 goes to the bottom. But because I got that negative in front of it, it'll become y equals -2/1, which is just plain old -2. Let's plot it. -1, -2 should be right about here. Okay, I know I'm going a little bit fast, but let's keep going. I'm just plugging and tugging right now. Calculators can be really, really useful when we get to this point. Then the last one. If I plug in -2, y equals -1/2, it's the negative second power. Okay, just like before, when I distribute this -2, what's going to happen is the top and the bottom flip, and I'm squaring the top and I'm squaring the bottom. So basically what this is, it should be negative in front, 2 squared on top, which is 4, and then 1 squared on bottom, which is 1. Negative in front, when I plug in -2, I should get back -4. -2, 2 units to the left, 4 units down, which is right here. Okay, got a lot of points. Now what I'm going to do is I'm going to connect the dots. So this is the first time our graph is not going up and to the right. This time it looks like it's going down and to the left. It starts off super flat on the right side. We notice it curves down towards the left. Okay, a little bit more complicated. Basically, it's just the flipped version of this guy on the left. Okay. Once again, super useful. Start using calculators. It's a lot of work to do by hand, but I've done a lot of practice at it, so I'm okay at it. But use graphing calculators. Use any sort of calculator that could be useful to make sure you don't mess up these computations. One slip up can make a huge difference. Okay, but once again, it's asking, what is the y-intercept of this thing? What is the point at which this graph crosses the y-axis? It looks like it's right here. When I plug in 0 in for x, I should get back -1. -1 is the y-intercept.